Hello YouTubers, कैसे आप सब लोग? Hope you are doing well. So today I have come with another interesting new video in our 3-dimensional geometry lecture series, lecture number 24. So today we are going to discuss the theory equation of a plane passing through three non-collinear points. And to prove this theory, we are going to use the concept what we have discussed in our last lecture, lecture number 23, that is equation of a plane perpendicular to a given vector and passing through a given point. And in that lecture, we have used the beautiful wooden mathematical model. This is our plane, this is the vector. The plane is perpendicular to this given vector and passing through this given point. What is the equation? Vector equation we have derived. If you are a serious student, put the answer in the comment section below. So this equation is r vector minus a vector dot n vector equals 0. That concept we are going to use today. So without wasting any time, let's go to the blackboard. So first we will draw the diagram and write the preliminary things. Okay, proof. Let R, S, T be the three non-collinear points on the required plane whose position vectors are a vector, b vector, c vector. Here, why we are considering these points as non-collinear points? Have you thought about that? Because if we consider this plane and if we take 3 points here, then these 3 points are collinear because they lie in the same line. In that case, infinitely many planes, each page of this book can be considered as a plane passing through these 3 collinear points. So in that case, we are not having a unique plane. So to get a unique plane, we must consider the 3 points given in the space non-collinear, like that. You can say here 1 point, here 1 point, here 1 point. They are not what? They are not collinear, that is they are non-collinear. So we have to find a equation of a plane passing through 3 non-collinear points. So here R, S, T are non-collinear points. See the diagram first. It's a very interesting theory. And my suggestion is that don't skip any theories discussed in 3-dimensional geometry, because in future when we are going to solve problems, each and every theory are useful. They are interconnected, okay, interlinked. So if you miss or skip a single theory, then you will get in trouble while solving problems. So always remember that, not to skip any theory. 0. Okay. So here, say this point is R, this point is S, and this point is T. Then I join this like that. RS vector, this is RT vector, do RS vector, RT vector. Now see again in this model, if in this plane we are considering that R, S, T, 3 non-collinear points lying in this plane. So as R, S lies on this plane, so RS vector lies in this plane. Also R and T, point R and T lies in this plane. So RT vector lies in this plane. So now if we take the cross product of RS vector and RT vector, then we get RS cross RT vector. But what is the direction of the resultant RS cross RT vector? Direction must be perpendicular to the plane. Here we are using the concept of vector product. That's why I have repeatedly told you that in the three-dimensional geometry chapter we are going to use vector chapter concepts very frequently. So if RS vector is on the plane, RT vector is on the plane, so RS vector cross direction of RS vector cross RT vector must be perpendicular to this plane. So now if we consider a arbitrary point P on this plane, then this plane whose equation we are going to derive is perpendicular to a given vector, that is RS vector cross RT vector, and passing through a given point. That is the point where we are going to use the concept what we have learned in lecture number 23. That is the equation of a plane passing through a given vector, not passing through a given vector. Equation of a plane perpendicular to a given vector and passing through a given point, whose equation is, vector equation is r vector minus a vector dot n vector equal to 0, where a vector is what? The position vector of the given point, and n vector is the vector which is perpendicular to the plane. So here RS vector cross RT vector is perpendicular to the plane. Okay. Now let P be any point on the required plane whose position vector, P vector in short, position vector is R vector, say. Therefore, the equation of the next page plane passing through the point whose R, whose position vector is a vector and perpendicular to the vector RS vector cross RT vector is, what is the equation? R vector minus a vector dot RS vector cross RT vector equal to 0. For your reference, I am writing here, for your reference, R vector minus a vector dot n vector equal to 0. Follow lecture number 23. Here n vector is RS vector cross RT vector, because this RS vector cross RT vector is perpendicular to the plane, and here a vector is the R, that is the point R, is nothing but a point on the plane. So implies, what is the RS vector? RS vector means, now blue color, now RS vector means position of S vector minus position of vector of R vector. So B vector minus a vector. See, position vector of the point S is B and position vector R is a vector. Also RT vector, R also undo, also RT vector means position vector of point T, that is C vector, minus position vector of point R, so A vector. Here I have used the triangle of vectorization. Okay, here if we complete this triangle, you can get it easily. Here point R is a vector, here point S is given as RST, B vector, and here point T is position vector is C vector with respect to the origin. So now, therefore we simply put the values R vector minus A vector dot RS vector means B vector minus A vector cross RT vector means C vector minus A vector equal to 0. So this is nothing but one vector dot another two vectors in cross multiplication. So this is nothing but scalar triple product, that is box product. There is another theory we are going to use from the vector chapter. It may lie in the appendix section of NCERT vector chapter. Okay, scalar triple product, vector triple product. You can just go through, then you can understand everything. Okay, so now it can be written as next page. Therefore, R vector minus A vector, B vector minus A vector, C vector minus A vector. See previous page. Yes, from this is nothing but red, yeah, okay, underlined. So this is nothing but the scalar triple product or box product. I have written this like that, equal to 0. Say 1 is the required vector equation of the plane passing through 3 collinear points. No, non-collinear points. So you have to always be attentive while writing the proof of any mathematical problem. So non-collinear points. So here we have done, but still we have to find the Cartesian form. This is the vector form, vector equation. So I have underlined this. I will underline this like that. Okay. So now we are going to find the Cartesian form. Cartesian equation. Now let the points R, S, T and point P have coordinates as white R x1 y1 z1, S x2 y2 z2, T x3 y3 z3 and P as xy z respectively. Okay, so now if you go through the scalar triple product, then you can know very easily that it can be written as the form of determinant. So R vector minus A vector, what are the component of R vector minus A vector? One I will show, and the remaining B vector minus A vector, C vector minus A vector you will derive. It is given as home assignment. So next page, R vector minus A vector. Here R vector is x I cap, y j cap plus z k cap, and A vector x1 I cap plus y1 j cap plus z1 k cap. So R vector minus A vector equal to x minus x1 I cap y minus y1 j cap plus z minus z1 k cap. So we similarly derive the other components are b vector minus a vector and c vector minus a vector. Do it yourself. We just simply write here the determinant value. So from 1 we get, that is equation 1, we get determinant. See previous page. R vector minus a vector means x minus x1, y minus y1, z minus z1. And b vector minus a vector, previous page see, b vector minus a vector means b point B is this one RST, this one a vector, this one b, components of b vector, this one component of c vector, these are the components of r vector. So b vector minus a vector means x2 minus x1, y2 minus y1, z2 minus z1. x2 minus x1, y2 minus y1, z2 minus z1. So previous page, b vector minus a vector, then c vector minus a vector, c vector minus a vector. So x3 minus x1, y3 minus y1, z3 minus z1. See here, I tick that c vector minus a vector. Just subtract x3 minus x1, y3 minus y1, z3, undo z3 minus z1. Determinant value is 0. 2 is the required vector equation of the plane. So we are done. Now we are going to see an application of the theory what we have learned today. So without wasting any time, let's go to the next slide. So problem, find the vector equation of the plane passing through the points this. So we have to go and find the vector equation here. So r vector solution, white color solution. So r vector equal to, what is the equation, vector equation? Tell me. The vector equation of the plane is r vector minus a vector dot rs vector cross rt vector equal to 0. So here it is a vector, this is b vector, this is t vector, okay, c vector, okay. So r vector minus a vector, r vector minus 2 I cap plus 5 j cap minus 3 k cap dot rs vector cross rt vector. So here what is rs vector? Rs vector means b vector minus a vector, b vector minus a vector. And what is rt vector? Rt vector means c vector minus a vector. So here we will put the components I, j, k. Here we are using the definition of cross product. Again we are using the concept of vector chapter. So rs vector, b vector minus a vector, b minus a, b minus a. So minus 2, minus 4, minus 3, minus 5, minus 8, 5 minus of minus 3 means plus 3, 8. Again c vector minus a vector equal to 5 minus 2 means 3, 3 minus 5 means minus 2, and minus 3 of minus plus 3 equal to 0. So equal to 0 implies r vector minus 2 I cap plus 5 undo 5j cap minus 3k cap dot I cap. Here this one 0 minus 6 minus or minus 16 means 16 minus j cap minus 4 0 minus 24 plus k cap minus minus plus 8 minus 24 plus 24 undo 24 equal to 0. So now we will simplify this. Next page, r vector minus previous page 2I cap plus 5j cap 2 5 minus 3 2 5 minus 3, so 2I cap 5j cap 3k cap dot, see previous page 16I cap plus 24j cap 16I cap plus 24j cap, and previous page 24 plus 8, so 32k cap plus 32k cap equal to 0. So this is the required vector equation of the plane. My handwriting is very bad. Equation of the plane. So answer. So we are done. So we have come to the end of today's video. Hope you have enjoyed today's lecture, and my humble request to you is that please go through previous lectures, then come to these lectures, then you can understand everything very easily. Thank you.